Okay, I guess we'll get back to the movie making here. Made some progress with the AC measurement system. Found that by synchronizing the reading of the voltage register with the voltage zero crossing, that completely gets rid of the ripple that appears in that RMS reading, and we now have a nice stable, if it was 119.49 volts, which is exactly what the test set is putting out. I tested it from a range of 40 to 140 volts, and the accuracy was within 0.05% over that range. Same thing with the amps. The amps have always been stable. They have a high-pass filter in the amp circuit which gets rid of that ripple, and we also have a similar level of accuracy there. The watts, I made some progress on that, but I still have the jitter issue to a lesser degree, in the CF pulse output. I talked to Analog Devices about that, and they said to use a 1 in one of the registers, even though it has this range of it's a 12-bit register. If you use a 1 and set another register to the right ratio, it works a lot better. And sure enough, that's true, but that wasn't documented, and it's still not perfect. So you are still working on that issue. But that's the AC presentation. It's done. Looks pretty good because we're still working on the DC. And this website that you can go to look at this will be in the comments section. Once again, looking at the NetBurner mini server. It is used to serve this web page to the internet through my gaming router. And this, of course, is the circuit board. Once again, I have the voltage regulator here, the heatsink on it, the Analog Devices ADE chip is on that proto carrier that converts it to a 20-pin DIP. The 3.58 megahertz clock oscillator is right behind that. There's the Technological Arts 9S12 processor module, a couple of shift registers to run the display, and of course this is the 4x20 display that basically shows the same thing that's on the internet. So that is the grand tour. Next week, the watt-hour standard will be here, a very accurate watt-hour standard on order, and that will be used to get this thing down and prove the watt-hour accuracy. That's critical. We have 0.05% voltage and current accuracy. We want to prove the watt-hour accuracy. That's the money parameter right there, over a range of, say, 5 watts to 150 watts or whatever, 200 watts, and make sure we have very accurate watt-hour readings. So that's all, folks.